And this was Lab 4, Oscillations. This was Lab 4, Oscillations. The purpose of this lab was to observe a spring mass system in which the mass swings in an arc while oscillating on the spring by using Tracker and VPython to create a computational model of such a system with initial data taken from an observational model. The summation of the results after the lab was that the forces acting on the system are the spring force by the spring and the gravitational force by the earth. Energy is conserved in the system consisting of the mass, spring, and earth. The observed and computational model were very similar. The fundamental principles involved in this lab were the spring force and gravitational force equations and Newton's second law, which we used to model the motion of our system. In addition, we also used the equation for the period of oscillation to find the spring constant of the spring in our model. We also used the principle of conservation of energy, where the change in energy is equal to the work, which is equal to the change in kinetic energy plus the change in potential energy, and the three equations below to model the change in energies of our system. This was the observational model using the Tracker program. These are the initial conditions that we used in the observational model. This was the computational model using the initial conditions from the observed model and the calculated spring stiffness and initial velocity. This was the energy components in the computational model that we found using VPython, where the yellow represents the total change in energy. As we predicted, the yellow line is at 0, so the total energy change is 0, which means that in our system, consisting of the mass, spring, and the earth, there are no interactions with the surroundings and all energy is conserved inside the system. This is a graph of the x and y positions of the computational and observational models. As we can see, both the x positions and the y positions of both models are pretty similar. This was the calculation of observed oscillation periods using the x or y axes. The top graph measures the oscillation periods, or shows the oscillation periods, in the x-axis, which means how the system moves horizontally, or the mass moves horizontally. And the bottom graph shows how, using the spring, the mass moves up and down. These are similar but not the same, which means that the position of the mass is never going to return to the same point that it had been previously. In summation, as before, the forces acting on the system are the spring force and gravitational force. Energy is conserved in the system consisting of the mass, spring, and earth, which we showed with the yellow line of total energy being 0, and the observed computational and observational models were very similar, as shown in the x and y position graphs.